Hello, my name is Gerardo Murga. I'm an undergrad at Stanford studying the Bachelor of Science of Economics and a computer science minor. And this is my CS109 project, which I've poured my heart into. So I hope you guys really like it. I'm an international student from Mexico, and I have a very big and very tight-knit community within my family. So whenever we have to get a loan, we can choose either to get it through traditional credit or we can directly ask our family members for a 0% interest loan. This reality is very different from what many people in developing economies around the world are facing. They usually have to go through an informal lender that charges very high interest rates or a microlending company, which is basically the same but institutionalized, right? For this video, I'm not going to explain like the full thing, but I will just show you guys a gameplay plus an intuitive explanation of how this is working and how at a certain threshold of interest rate, the people just fall into an unescapable debt cycle. All right, so we're at the opening page. Let's start. I drew this guy by hand. The credit score is calculated with 33% friends network, 33% the payment history of the person, and 33% amount owed. Plus, there's a savings bonus. Depending on how much money you've saved, you can get an additional credit, even past the 100 at this case, right? Um, there are three people in the network. Each of them have different characteristics. For example, Mike has a credit of 20. His favorite sport is chess. He doesn't like dinosaurs. He has a score of texting clients of 1, which is not good. And the number of successful businesses that he has is 0. So that's why Mike has a very low credit score, right? Eduardo is like halfway there. He likes a couple of different things, and Elisa is like she's the best. She has a credit score of 100. She likes golf. Also, for this scenario, liking golf helps you in your credit score because you get access to more business connections. But this is like obviously not always true, and it might turn to bias. So we have to be very careful when computing a real life model of this. So depending on your network of like people, and like the user can select the sport. Like let's say you select golf and you run one simulation, you can see that there are different probabilities that you are friends with either of the networks. For example, there's no way you're friends with Mike because you have such a high credit score, and assuming that good businesses like making business with other good businesses. So the probability that you're making business with Mike is not very high. And the network credit is like the weighted average of the friends' credit scores. You can also see the loan. The loan random variable depends on the credit score that you have. So like the higher the credit score, you can get a higher loan. And there's also a higher chance that you get a positive profit, right? Like that you get a bigger profit. You can run the simulation multiple times. You can see the numbers, the savings just grow. But what happens if the interest rate just turns to like 1%? We can see how the credit score just starts to tank and the amount owed as well. This is not good. And like once the credit score is super high because the interest rates were really high, then it becomes really hard for the person to catch up, even if interest rates are like really low later. Let's see how this goes. As you can see, it's very hard for the person to catch up, and this forms an unescapable debt cycle. You can see also like the stats that their character has that will be taken into account when calculating the probabilities that you are friends with Mike. This is the code I wrote with support from Claude. I wrote a Python version before to make sure that the game worked correctly, and then I iterated like for many hours to try. All right, so now let's explain the Bayes net that computes the probability that you're friends with, like with each of the players in the game. So the user can only input the sport that you like, because although there are 4 different inputs, which are like payment history, amount owed, and hour spent on screen. Hour spent on screen is based on a normal random variable with predetermined traits like mu and the variance. The amount owed and the payment history are calculated through the game, so the user can only control this and the interest rate. If you like football, you have a lower chance of liking dinosaurs. If you like chess, you have a higher chance of liking dinosaurs. And if you like dinosaurs and the other person likes dinosaurs, then that will contribute to the probability of being friends by a certain amount, right? That's calculated through this formula. So it's like based on an expected value. Then we have hours spent on screen. They affect the number of successful businesses, and the amount owed and the payment history. They get calculated on a score from 1 through 5, 1 being very bad, 5 being good. This affects the number of texts with clients. The number of texts is simulated by a normal random variable with a mu of this formula that takes into account like the scores of the 2 others above and a variance of 25. The text score is then calculated as an integer. But many of these decisions were calculated as a way to make sure that the probability made sense overall. But these numbers can be changed in the functionality of the program. Both hours spent on screen and number of texts with clients affect directly the number of successful businesses that you can have. So if you play golf, you assume that you have more business connections, so you have 2 more successful businesses by standard. If you spend more than 3 hours on screen, it means that you're doom scrolling. If you spend less than that, it means that you are not working because you're supposed to be texting clients. So the closer you are to 3 is the best. So all of these variables, or like not all of them, but 4 of these then directly affect the probability of being friends, and they contribute each differently. Always comparing the scores of the friend and your own personal scores. And finally, you get a Bayesian update model with a prior and the contribution for each of these nodes. And that's it. I hope you guys enjoyed it. I wish I could have more time to talk through it, but have a great day. This was a great project to work on.